So we want to solve the equation secant x equals 7/3 and approximate the solutions which lie on the interval from 0 to 2 pi to 4 decimal places. So I could take the inverse secant of both sides of this equation, but the problem with that is I don't have an inverse secant button on my calculator, and this isn't a value that I know the exact value of. And so what I'm going to do instead is take the reciprocal of both sides. 1 over secant x is cosine x, and then the reciprocal of 7/3 is 3/7. Now, if I take the inverse cosine of both sides, I will have x equal cos inverse of 3/7, and that's something that I can use my calculator for. So let's just think for a minute though. When I use my calculator, inverse cosine is a one-to-one function. I am going to get out answers between 0 and pi. So for this particular one, since the inverse cosine is positive, I'm going to have an angle in quadrant 1. So let's go ahead and get the calculator. So let's bring up the calculator. I'm going to make sure I'm in radians. Then I'm going to do inverse cosine of 3 divided by 7. And there's my first answer. It's going to be 1.1279. So we have x equal 1.1279. And now I need to ask myself, where is another place between 0 and 2 pi that would have a positive cosine? And that would be here in quadrant 4, that have the cosine the same value of 3/7. And so how would I get at that angle? Well, I have this angle here, which is the same as this angle here. So if I did 2 pi and then minus that angle, I would have the angle I need. So I'm going to pull the calculator up, and I'm going to put in 2 pi, and then I'm going to subtract, and I'm going to just use the second answer here. And that's my second angle that has a cosine of 3/7, which is 5.1553. X equal 5.1553. So they have a cosine value of 3/7, which means they have a secant value of 7/3. Now let's go ahead and look at the same equation, but if it were negative. So I'm going to do the same thing. I'm going to take reciprocals of both sides. So I have cosine x equal negative 3/7. Take the inverse cosine of both sides, and x equal cos inverse of negative 3/7. Now let's draw a picture and think about this again, because this time I know that it's a one-to-one function and it's going to give me angles something between 0 and pi, but the cosine value is negative, so it's going to be something here in quadrant 2. So it's going to give me this angle here in quadrant 2. So I'm going to do inverse cosine of negative 3 divided by 7, and I get this angle in quadrant 2, that is 2.0137. So we'll write that one down, x equal 2.0137. So now I need to ask myself, where else between 0 and 2 pi is there an angle that has that same cosine value? And I can see it would be over here in quadrant 3. I can see that the x values there would be the same. So how could I get at that angle? Well, this upper angle over to here was 2.0137. Well, if I'd go around the other direction, negative 2.0137, I would have the angle I need, except for the fact that that angle is not between 0 and 2 pi. But if I added a loop around, a plus 2 pi, then I would have that angle in quadrant 3. So I'm going to take 2 pi, and I'm going to subtract that angle that I had in there, and I will get my second angle, which is 4.2695. So x equal 4.2695. Now, both of these angles have a cosine value of negative 3/7, and they have a secant value of negative 7 thirds.